Okay, so today we're going to be doing some math. When you think about IT 140, you think about networking, you don't think about mathematics, but subnetting is mathematics. When we think about the IP addresses that IANA have given us, we've only got a finite number, and we need to be able to equitably distribute those to all of the resources on our network that need to have an IP address. What I want to do today is get us started with the process of subnetting. Before we do that, though, before we can run, we got to walk. Before we can walk, we got to crawl. And I want to take us down to the base level of the knowledge we need to do this successfully. I want to ask you, what is the base unit the computer understands? It doesn't understand my English. How does the computer, what does it understand?
Binary.
Understands binary. And binary is what?
Ones and zeros.
Ones and zeros. So it's ons and offs, electrical ons and offs. So when I think about how we measure things or talk about things in a computer, we often use the word byte. How many zeros and ones is in a byte?
8.
8. Excellent. So a byte's going to look something like this. A byte is going to have zeros and ones, and it's going to have 8 of them, and they could be any combination. I'm just making this up from my head. Give me another number that I might put in there to complete this byte.
1.
1, okay. Before I do that, this is what they call a nibble. 4 bits is a nibble. Each one of these is a bit, and this is what they call a nibble. To make a byte, when you 8 of these, I heard a 1. What else?
0.
0.
1.
1.
0.
0. Okay, do we have 8 of them? 1, 2, 3, 4, 5, 6, 7, 8. We do. That is a byte. Now, this is base 2 numbering, these zeros and these ones. But our IP addresses are in what they call base 10 numbers, like a 192 address. 192 is a base 10 number. We have to be able to take a number like this and convert it to a base 10 number, and we have to be able to take a base 10 number like 192 and convert it to a byte. So we want to get some paper and pencils out right now. Get your papers and pencils out. I want you to follow along with me as we go through this process of taking a base 2 number, a byte like this, and converting it to a base 10 number. So we're going to take and draw a little tool on our notepads there. I'm going to draw this table. So everybody draw a table like I've drawn. And then we're going to divide it up. Draw some lines like that. And up in the very top left corner, I want you to write the number 128. And then I'm going to ask you, what is half of 128? Anybody?
64.
64, good. So we're going to draw a line here to divide that. 64. Okay, math people, help me out again. What is half of 64?
32.
32, good. And half of 32?
16.
16, you guys are getting the hang of this. And we continue. Half of 16 would be 8. Half of 8 would be 4. Half of 4 would be 2. Half of 2 is 1. And that's where we stop there. Now, we're talking about base 2 numbers. We can talk about the powers of 2. I'm going to start over here underneath the number 1, and I'm going to write 2 to the 0 power. Anything to the 0 power is 1. I'm going to go underneath the 2 now, and 2 to the first power is 2. Math people are starting to see a pattern here. I'm going to say on the next one under the 4, 2 squared. 2 times 2 is 4. Underneath the 8, I'm going to write 2 cubed, or 2 to the third power. And 2 times 2 is 4, times 2 is 8. And we continue up all the way. Under 16 is 2 to the 4th. Again, the pattern people seeing where I'm going with this. 2 to the 5th under 32. 2 to the 6th under 64. And 2 to the 7th under 128. Okay. Now, let's put that byte that you guys came up with in my tool that I'm going to use to determine what that byte would equate to in a base 10 number. I'm going to put the 0 over here, and then the 1, the 0, the 1, the 0, the 1, and the 0 in there. I want to take that byte and I want to convert it to a base 10 number. To do that, I'm going to take every column that's got a 1 in it, I'm going to take that number. So the first one, I look out on the left here, starting from the left side, put a little check mark there. The first number I have with a 1 in it is 64. I'm going to put that 64 down below my table with a plus symbol. And then I'm going to look for the next one, and it's right here in the 16 column. I'm going to add 64 plus 16. 6 and 4 is 10, carry the 1, 7, 8. I've got 80. Check my math. Then I'm going to put another plus symbol, and I'm going to come to the next column with a 1 in it, and that has an 8. 80 plus 8 is 88. Again, check my math. And then the final column with a 1 in it is a 2. Put a check mark there. 88 plus 2 equals 90. My base 10 number that's equivalent to that byte that you came up with is 90. Now, there's a great way for us to check this number to make sure. So we can work it in the opposite direction. We could take a base 10 number, use that very same tool that we created to check and see if we have a match. That if 90 is a base 10 number, it equates to that same byte. So I'm going to do that. I'm going to get my eraser out. I'm going to take and remove these markings that I put up here. You guys remember the number 90. Keep that up there in your minds there. Put that down somewhere in your notes just so we can check me after we do this in reverse to determine that it indeed is the same number, only in base 10 versus base 2. Okay. Now, guys, it was 90, right? 90? Okay. I'm going to put 90 up here. And I want to take this base 10 number 90 and I want to make it into a byte like that. To do that, I come over to my first column on the left like we did before, and I say, is 90 greater than or equal to 128? Is it?
No.
No. Okay, good. So I'm going to put a 0 there because it's not. And then I'm going to come over there to the second column and say, is 90 greater than or equal to 64?
Yes.
And it is, you're right. So we're going to put a 1 there. And I'm going to take 64 from 90, and math people help me out. What is that?
26.
26, the math people are saying. Okay, good. So now, I've got 26 I'm working with. Is 26 greater than or equal to 32?
No.
No. So we're going to put a 0 there. And then I carry that over the next one. I say, well, is 26 greater than or equal to 16?
Yes.
And it is. So I'm going to put a 1 here, and I'm going to take 16, and I'm going to subtract that from 26. 26 minus 16, last time I checked, was 10, but again, check my math. Is 10 greater than or equal to 8?
Yes.
It is. So I can put a 1 here, and I can take 10 minus 8, and that gives me 2. Is 2 greater than or equal to 4?
No.
Okay, so I'm going to put a 0 there. Is 2 greater than or equal to 2?
Yes.
Okay, so I can put a 1 here. And
Now
2
we're at 0.
minus 2 is 0. Is 0 greater than or equal to 1?
No.
No, so I'm going to put a 0 here. Now, let's check my number. I hope we have a match. I've got a 0 here in the first column, 0, okay? 1, 1, 0, 1, 1, 0, 1, 0. I have a match. So we determined here both ways that my base 2 number, my byte, 0, 1, 0, 1, 1, 0, 1, 0, is equivalent to the base 10 number 90. And we did it both ways. Okay. Any questions about that? All right. Now, this is all well and good.